Hello, everyone. I know we're behind time, so I'll make sure I keep it prompt. Thanks for having me. I will talk to you today about ZK rollups and Scroll. So Vitalik just spoke about L2s, and Scroll is a ZK rollup and L2 on Ethereum. And we'll touch upon some of the points actually that Vitalik mentioned, so that's pretty cool. So before I'm going to talk about, Scroll and where we're going with Scroll and why I use Scroll, I want to talk for a minute about how ZK is used for scalability. I've had the pleasure past week to talk to a lot of devs, to a lot of folks here in the space. So it was actually not always well understood, like how ZK is used in scaling. So I usually tell this story, and hopefully through that we'll be able to understand how ZK is used in scaling Ethereum. So in a land far, far away, there's a king, and this king requires, all his citizens to show transactions for every purchase they've made. But the king is not happy because he needs to check every transaction, and the king gets sick of it. It takes a lot of time, and time is money for the king. So the king says, you know what, I'm going to hire an accountant. This accountant is going to check all the transactions, and if I see a report with the stamp on it, then I know everything is okay. Everyone has shown their receipts. But what if the accountant is evil and starts to say, if you pay me a little bit money, I will make sure there's a stamp on the report. King still not happy. So what the king does is, he gives a computer to the accountant. It says, you put all the receipts in the computer, and all this computer does is checks if the transactions have a receipt or not. And then the king gets a report from the computer, and if the stamp's on it, great. The king, knows everything is okay. So the king is happy now. And in this case, what I just explained is how a rollup, in simple terms, actually a ZK rollup scales Ethereum, where, in this case, the accountant would be, the L2 Scroll, where we all post our transactions, and we have a proof system that checks each of these transactions for its validity, making sure that, these proofs are valid. These transactions are valid. And then it generates a ZK proof, and it shows to Ethereum together with the transactions, these transactions are correct. So Ethereum can trust, and users can trust that these transactions are correct. So then when we look at the Scroll architecture, it looks a little bit like this. So we have over here the layer where users interact with Scroll. They create transactions, send it to the sequencer processes it. Then parallel to that, we have a prover network that takes these transactions. We've got circuits, so-called circuits, that basically prove that these transactions are correct. And then together with the transactions and the proof, we post it on Ethereum inside a rollup contract. And we'll see in a bit why this is super cool, because it basically means that anyone could access all this data on Ethereum that lives on Scroll. And so this is a more elaborate view. If anyone in the audience is a developer, I'll be here hacking all night. Reach out and I'll happily walk you through this. So finality, when transactions are processed on Scroll, how long does it take for it to be available on Ethereum? So one of the things that, and we'll touch upon that in a bit, is not all rollups are created equal in here. So when you create a transaction 1 to 2 seconds, it's actually already available on Scroll. Then there's the committed phase, where if I go back, you'll find that we actually commit the transaction data in about a couple of minutes on Ethereum. So this data would be available in a couple of minutes to you on Ethereum. And then it takes about 10 minutes to also post the ZK proof that these transactions are valid. So that's called the finalized state. And so, no shade. We'll talk in a bit why a ZK rollup has an edge. But before I actually go into that, all L2s are Ethereum. We have a good relationship with other rollups. This is Pseudo on Twitter shouting out Polygon. Sandy, one of our co-founders, shouting out the OP Labs. They recently implemented or starting to implement fraud proofs. And Togrel, who was supposed to be here, supporting the Solana ecosystem and Polygon ecosystem. But what is the main reason why I'm saying this? It's because when you look at the finality that I've just mentioned of 10 minutes, it basically means if you make a transaction, let's say you create an NFT or transfer an NFT from you to your friend on Scroll, but at any given time you'd like, hey, I want this to live on Ethereum, you can post this, you can bridge it back to Ethereum, and it will be available to you in a matter of hours. That's not the case for OP rollups, because OP rollups work different. They have an arbitrary period of 7 days. Now, an NFT might be very valuable to you, but in terms of funds or very sensitive data that you want to have access to immediately, you don't want to wait for 7 days. And so this is one of the benefits of a ZK rollup, which is referred to often as finality. So because the finality is quote unquote instant and so quick, it means that at any given time you want to access your data, you could. Now, by the way, I know there are bridges that will allow you to bypass and get access data to your funds or get access to your funds quicker on Ethereum, but that's just a general purpose. So EVM compatibility. Another thing about ZK rollups is you must have heard, maybe you've heard about the type 1 versus type 4. In simple terms, some ZK rollups are closer to EVM, which provides a better developer experience. What that means is Hardhat, Foundry, all these dev tools that you use work quote unquote out of the box. That's not the case for every rollup. And that has everything to do with when a ZK rollup is created, there are design choices to be made, whether the virtual machine, so where your data is processed, if it is going to be close to how the Ethereum virtual machine is designed, or choose for a different virtual machine, which has a better performance, in other words, for proof generation, but it does mean that some of the dev tooling, for instance, and smart contract designs wouldn't work out of the box for a rollup like that. And this is typically referred to as language compatible versus bytecode compatible. And at Scroll, we are bytecode compatible, which means when you deploy an app deploy a smart contract on Ethereum, that smart contract will act and behave exactly the same on Scroll. So now that we've spoken about the trade-offs of why ZK rollup, there are quite a bunch of ZK rollups out there. Why Scroll? And I want to take a minute to talk about security. One of the things that keeps Vitalik up at night, he mentioned, was, for instance, the bugs in verifier contracts. So, and this is something that just gonna delete this, go / This is one of the things that we aim to tackle with our multi-prover implementation. So what's better than one prover? It's 2 or 3. And in simple terms, we've got a blog post diving into this, but we implemented a multi-prover implementation that allows not one, but multiple proofs to be generated to validate and verify transactions. And this is because we take security very, very, very serious at Scroll. And the concern that Vitalik has is rightfully so, because it's one thing to prove that these transactions are valid, but there could still be a bug somewhere in the circuit, and you want to prevent that. And so when you're dealing with funds or sensitive data, security might not be the sexiest thing, but no one cares about security until we do. And again, not going to throw shade. We've seen lately what an L2 has overcome when an exploit happens. Well, security prevents that. So this is one of the reasons why Scroll stands out. And this is a good overview of, let's say, where a validity proof lives versus where a ZK proof lives versus, where multi-prover lives. And we really aimed to make sure that it doesn't impact finality, i.e., the time it takes to commit and post this data on Ethereum, and it doesn't impact gas costs. So it has very, very minimum impact on gas cost. And I already touched upon this a little bit, but I'll dive into it more, which is ZK compatibility. So not all rollups are created equal. Today, if you want to do applied ZK, i.e. you want to integrate zero knowledge proofs into your application, you're going to have to actually review whether that rollup can use the DSL, so domain-specific language, or the SDK before you can use it. And so in simple terms, what happens is you have off-chain where a circuit runs, and on-chain is where the verification of that proof happens. This is an extreme oversimplification of how a zero-knowledge implementation works. And so the things that you need to check is, does my chain support all the curves, all the hashing, all the precompiles? And also, what does the performance look like, the verification time? Does it work client-side or not? And that's more on the application side. And so more compatibility. We are almost there. End of April, start of May, where we're going to have an upgrade where blobs will be introduced, so gas fees will go down significantly. That was the talk of Vitalik, but also SHA-256. It's a hashing, it's a hash mechanism that right now is not supported on Scroll, but we will have it supported and proven in our next upgrade. And something, if you're into it, EIP 1559 won't be there yet, but it will be in the next upgrade. But it doesn't really impact the performance or the development of your application. It's more or less a representation issue. So better security, better finality, better DevX. And I'm pretty happy to share with you guys that last year we had a very rapid growth of our Scroll ecosystem because of basically these principles that we adhere to: a high level of security, a high level of reliability, making sure that we're able to provide the best developer experience, and that was definitely noticed. And so one of the things that, again, I want to underline is that technically speaking, on Ethereum, you could quote unquote query may not be the right word, but retrieve and access all the data that lives on Scroll. And so technically speaking, an application could interact with all the data that lives on Scroll on Ethereum through the rollup contract. Finally, I will say, why Scroll? Community first. I know that's been said a lot, but we're looking at ways where we're listening to our community. What are ways where we can bypass gas fees? We're actually even thinking about what does it work without gas fees, from a user experience look like. A home for DeFi. So what does good incentivization look like, native yield, and then finally supporting devs and projects. We've got a bunch of cool stuff coming up. We're launching a program to help devs, that really want to build, connect them, let's say, with ecosystem partners as well. We're launching this soon. We're launching a platform called Level Up, where if you want to build on Scroll, you don't know where to start, we'll help you all the way get there. And then alpha there is end of April. We're going to do an online hackathon, our first ever Vortex, where we've got about almost 100K in prizes. If you have more questions, I'll be around, walking around. I try to give you a quick walkthrough. Obviously, when it comes to details or a specific implementation or specific detailed questions, they might be different. Feel free to reach out. If you're a builder, feel free to reach out. Love to talk. This is where you can find me on the internet, at Raza Codes everywhere. Thank you very much.